Right, so let's touch on this thing that we're going to call the quantum realm. But basically, it's just the physics that describe how things work when they're really, really, really small. So what we'll say is that classical physics explains everyday life. Right, if you throw a ball up in the air, it'll come back down, that kind of thing. To go from 60 miles an hour to 65 miles an hour, you have to pass 61, 62, 63, 64, that kind of thing. Unfortunately, a lot of these rules break down when things get small. So back to our TV analogy. If we think about this image of this cat, everything looks nice and smooth, right? It looks like there's curves and that kind of stuff. But when we zoom in, what we see is that we have pixels, right? That we don't actually have any smooth lines. We have jagged lines because everything is made out of these little squares in the case of the TV. And so that's somewhat similar to what goes on when we get really small in the real world. And so what we call this is quantum or quantized. And all this means is that only some values are allowed. And so we can have a little analogy here. So we can have, on the left side, we're going to have a ramp. And we're going to call this our classical or continuous. And it's a ramp. And then on the other side, we're just going to have some stairs. And that's going to represent our quantum world. So if we think about our classical world, we can put a ball anywhere and it'll fall down, right? Put a ball up there, put a ball down there, and it'll fall down, right? So the ball falls from here or it falls from here. And when it falls from there, it releases a certain amount of energy. And we can place the ball anywhere on this ramp so the ball can fall from any height. It just depends where we put it on the ramp. On the right side, we have our quantum staircase. So for example, we could put a ball on this staircase and we could let it fall down, or we could put a ball on this staircase and let it fall down. And so that kind of represents the two heights that we can fall from. And what's weird about the kind of quantum realm is that values in between these two heights are not allowed. So if there's any distance between these, it's not allowed. So in between, no, right? So back to the kind of speed analogy, in the continuous world, we go from 61 to 62, 63, 64, 65 miles an hour, and everything in between. Whereas somewhere in the quantum world, we'd go from 60 directly to 65 and not be allowed to go anywhere in between. So we'll say that the ball can only be at certain heights. And this is one of the main principles of quantum mechanics, is that only some values are allowed. And that's very different from our classical physics, where we have all intermediate values being allowed.